Okay, let's read this example together. An 800 Newton person is involved in a tug of war with a 600 Newton person. So I have two persons. One of them is 800 Newton, the weight of him, and the other one 600 Newton. Okay, involved in a tug of war. The 800 Newton person pulls on the rope between them with a 400 Newtons of force. So the first man, he's pulling the rope with 400 Newton of force. If the rope is not slipping, focus on this sentence. If the rope is not slipping, how much force does the 600 Newton person pull with at the other end of the rope? What do you think the other man is what? For sure, the same force, because they said if the rope is not slipping, the rope is not moving. So what does it mean? It means the two forces are equal and opposite. The first one applied a force of 400 Newton, so also the second one applied a force of 400 newtons. Okay, this is Newton's third law. Let's see here question. It's a very important question. Focus on this one, please. A 10-kilogram mass is pulled to the right along a rough horizontal surface by a string. Girls, in these questions, always focus while you are reading because each word has a meaning. A 10-kilogram mass, this is the mass, 10 kilogram, is pulled to the right along the rough horizontal surface. It means that we have friction from the word rough surface. By a string, it means that this force here, it is the force, what do you call it? Tension force by a string. The string has a tension of 20 newtons. So the tension force is 20 newton. Determine the acceleration of the mass if the coefficient of kinetic friction between the mass and surface is 0.10. Good. What is the coefficient of kinetic friction? You remember? The formula for friction is what? Frictional force equals mu times normal force. Now, mu is coefficient of kinetic friction. Here it is given. Okay, girls, you feel at the beginning that this question is complicated, but you have to read the question again and try to analyze it. Focus with me to see how to solve all questions, the same idea as this one, step by step. Always in these questions, the first step, you have to draw a free body diagram of the question. This is the first step. Sketch a free body diagram. In this question, what do we have? Here, we have force of gravity for sure, because the object is on Earth. Okay? There is a mass to wear it down, force of gravity. And also because the object is on a surface, it means that we have normal force toward up equal and opposite to the force of gravity. Let's look at right and left. The forces on the x-axis. On the x-axis, what do we have? They said string, so we have tension force here. And to the left, because we have friction, you have to know and remember by yourself that the friction always is opposite to the direction of motion. So here is the friction. So the first step, to sketch a free body diagram. Second step, you have determined the type of motion. Here, the type of motion is what? The object is moving right, so horizontally. But we have forces on the y-axis and we have forces on the x-axis. So what do we have to do? We want to analyze to see what type of motion we have. Now on the y-axis, we don't have, the object is not moving up and down. So what does it mean? The object is at rest on the y-axis. We don't have a vertical motion. So in this case, we say that the forces are balanced. Okay, because the object is stationary on the y-axis. Balanced forces, it means that the sum of forces equal 0. Sum of forces equal 0. X direction, We have acceleration because the object is moving to the right, so we have acceleration. They didn't mention the word constant velocity, so you have to know that there is acceleration, and they said in the question, determine the acceleration. Sum of forces equals mass times acceleration here, Newton's second law. So on the y-axis, Newton's first law, in the second axis, in the x-axis, Newton's second law. Okay, now let's see. Sum the force vectors in the relevant direction. What does it mean? We want to see on the y direction what forces we have. Sum forces on the y equals n minus fg. What does it mean? Some forces in the y equals 0. So what are the forces on the y? We have normal, we have force of gravity. Normal toward up, force of gravity toward down. So we write the signs. We know that north always positive, south always negative. So n minus fg, positive and negative, okay? It has to be n plus negative fg, okay? But direct, you can write n normal minus fg. On the x-axis, what do we have? Tension to the right, force of friction to the left. So T plus negative F or T minus F. This is the third step. Look how we solve step by step. Now the last step, just write here instead of sum of fy, what you have to write? 0. Here instead of sum of fx, what you have to write? ma, and substitute and solve. Let's see the last step. In the y direction, n minus mg equals 0. Normal force, I don't know it, I don't have it. And we don't have a formula for normal force, we said that before. Minus force of gravity, we know the formula for force of gravity. It is mass times 9.81. So you multiply the mass, 10, it's given in the question, with 9.81. We said here in your environment book they use it 10, but we want to continue using it as 9.81. Okay, so then the answer for normal force is what? 100 Newton. The x direction now. In the x direction, what we will write? Sum of fx, instead of it, I will write ma. Look here, ma equals T minus mu n. What is this? T is the tensile force minus force of friction. Force of friction also has a formula, so you write the formula of force of friction. What is it? Mu times normal force. Mu is given in the question, 0.10 coefficient of dynamic friction and kinetic friction, and normal force, we found it now, it's 100 Newton. You multiply, you substitute, and multiply and find the answer. The answer for acceleration is 1 meter per second squared. Okay? These are the steps to solve any question asking for acceleration. Don't forget these steps. Try to solve the question alone by yourself to make sure that everything is clear with you and you got the idea of the question. Okay? Let's continue. Here is another example. It is a homework. I want you to solve it by yourself. Later, I will present for you the answer or solving for this question. Don't forget, girls, what you have to do here, when you have a force with an angle, you have to resolve it into two components, x and y. Don't forget this note.